Good morning, students. This is Kirti ma'am and this lecture for class 10th maths. So students, in this session I am going to prove a theorem which is basic proportionality theorem, that is Thales theorem. This theorem is given by the Greek mathematicians Thales, which are very useful and important for finding that the corresponding sides of equiangular triangles are proportional, that is, two equiangular triangles are similar. So this is called the Thales theorem or the basic proportionality theorem. So the theorem says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in a distinct point, then the other two sides are divided in the same ratio. So if line is drawn parallel to one side of a triangle and intersect the other two sides in distinct point, so you can see here A, B, C. This is the triangle and DE is the parallel lines. A line is drawn parallel to one side, that is DE is the line which are drawn on one side of the triangle to intersect the other two sides, which are intersect the other two sides, that is AB and AC. These AD intersect AB and AC sides in distinct point. Distinct points means D and E, this points. Then the other two sides are divided, that is AD and DE. AD and this is DB. DB. Divide is equals to AE and EC. So this is the statement of the Thales theorem. Now we have to prove the theorem. First of all, we have to construct a line BE and AD and two perpendicular line DE, DM and EL on the side AD and AE. Consider a triangle ABC such that DE is parallel to BC and DE, this is DE, intersects side AB and AC. So this DE is intersect side AB and AC. AC at D and E respectively. So these two lines, this line DE which are intersect AB and AC at point D and E. So now we have to prove that AD upon DB is equals to AE upon EC. So first of all, now construct a line. Construction is make a line BE and DC. Join BE and DC and draw a line which are perpendicular to AB. The line is EL. Draw EL is perpendicular to AB and DM is perpendicular to AC. AC. So this is the construction. After constructing a line, then we have to prove. So before starting a proof, I have cleared you some basic theorems which are going to use in the proving. So this is the triangle A, B and C. If this is the perpendicular line D, which are perpendicular on the side BC. So the area of triangle ABC is half into base into height. That is 1/2 into base is BC and height is AD. So this is the first point which are going to remember. Second is, let's make an triangle like this. Let's make a triangle like that. This is the triangle A, B, C. So the perpendicular lines which are drawn like this, which is D. So the area of this triangle, ABC is equals to half into base into height, where half base is this BC, because the perpendicular line is drawn on this side BC and height are AD. Last thing is, if any triangle like that, this is the two parallel lines and the triangles makes between these two parallel lines like this, and we name it A, B, C, D. The two triangles are this one and this one. So we can say that these two triangles are equal. Area of these two triangles are equal. So the area of triangle ADC is equals to area of triangle BCD, because these two triangles lie on the same base, that is DC, because these two triangles lie on the same base DC and between the same parallel line DE and BC. So that is the reason, because these two angles lie between the two parallel lines. These parallel lines is DC and AB. So these three basic points which are used in the theorem. So now let's start the theorem.